Well, there's my theme music, my very favorite current TV show. I can't wait for Monday nights, and perhaps we'll see if any of you guys recognize that one. Our title today is Simplifying Mixed Expressions. And basically what we're going to do is we're going to take all the tools and tricks you've learned over the past 3 or 4 lessons and kind of combine them all into one gigantic problem. Specifically, we're going to see a combination of both adding and subtracting combined with multiplying and or dividing, all within the same problem. And as we attack that, I just want to remind you of something that you spent a lot of time in middle school talking about, and that was our order of operations with PEMDAS. We're going to focus on cleaning everything inside the parentheses as much as possible, and then we'll graduate and we'll talk about multiplying and dividing, and then finish with our adding and subtracting. So let's go ahead. We've got 4 examples on tab today, and we'll jump right into the first one. Our first problem is asking us to multiply 2 rather ugly binomials. We have our first binomial here in these set of parentheses, and then we have our second binomial over here in this set of parentheses. And I want you to think of this as like 3 miniature problems all combined into one. My first task is to simply subtract the 2 terms I see here in the first set of parentheses. That's problem number 1. Then I'm going to come over here and I'm going to add the 2 terms I see in the second set of parentheses. That's problem number 2. And then my third little mini problem is to multiply the 2 results I get after I do my subtraction and my addition. So when I look at my first set of parentheses, I'm trying to think of a common denominator, and I'm going to say that my common denominator is a y. So I can leave the first fraction as it is, and then what I'm going to do is I'm going to multiply my second fraction by y over y. And that's a little hard to see, kind of blended in there. But I'm going to get 4y over y. Just recall that 4 is really over 1. Then if I move to my second set, I also will have a common denominator of y. Therefore, the first fraction can stay as is. And I'm going to take my 4 over 1 and I'm going to multiply by y over y. And that'll give me 4y over y. Now, if I subtract my first 2 terms here, I'll get x minus 4y over y. If I add these 2, I'll get x plus 4y over y. Very similar to yesterday's lesson where we emphasized we're just adding the numerators there. The denominator stays the same. Now I'm almost all the way done. My last thing I need to do is I need to multiply these 2 fractions together. And what I'm going to do is I'm going to multiply this numerator here times this numerator over here. The nice thing you'll notice perhaps is I could either FOIL them all the way out, or I could recognize a shortcut. Yes, the shortcut is the fact that they are conjugates of each other, and because they're conjugates, we can go Florida style, first times first and last times last. So x times x gives me x squared, and then negative 4y times a positive 4y gives me negative 16y squared. And then I'm going to multiply this denominator times that denominator to get y squared. This is our final answer. Okay, our second example is another multiplication problem. We're multiplying 2 binomials together. A little feistier looking than our previous one. As we attack the first set of parentheses here, and I'm thinking about trying to subtract the 2, I've got to try to create my common denominators. The first one is good to go, I believe. And what I'm saying for this first problem, I'm going to say that my common denominator should be the quantity x minus 3. So what's going to happen is that the second term right here is going to turn into x minus 3 divided by x minus 3, which I think you'll agree is equivalent to a 1. Just certainly looks a lot different now. And then I'm going to go ahead and to subtract those 2 fractions, my denominator stays x minus 3. But one of the hidden bear traps here is how we're going to handle this minus sign. It's very important that we distribute that minus sign. In fact, I'm going to handle it like I'm going to turn it into a plus sign and distribute the negative like this. And I would encourage you to use the same technique. Now you can go ahead and just combine your like terms. I believe when I take this x and add it to the negative x, they'll cancel, and I'm just going to end up with a positive 3 right there. Okay, now we're ready to go tackle the second fraction or second set of parentheses. What kind of common denominator do you think I'm going to use? Hopefully you agreed that my common denominator should be a 9, which means my numerator here is going to stay x squared, and then that second term, I'm going to rewrite it as 9 over 9. Again, I think you'll agree that 9 over 9 is equivalent to the 1 that I had there originally. If we go ahead and subtract to the numerators, I'm going to get x squared minus 9. My denominator stays 9. Now here you've come to a point where you've got two options. You could go ahead and just multiply straight across right now. Numerator times numerator, denominator times denominator. But there is a little bit of a shortcut lurking here. What you'll notice is that the numerator over here factors, and it factors very nicely. And I'm going to encourage you to go ahead and we're going to factor that numerator. I'm thinking a difference of two perfect squares, x minus 3 times the quantity x plus 3 all over 9. And certainly we could cancel this quantity with that quantity. And we could also say reduce the 3 and the 9. We could say 3 divided by 3 is a 1, 9 divided by 3 is a 3. And looks like my final answer is going to be x plus 3 divided by 3. You may be tempted to cancel those 3's, but we've talked recently about the reason we cannot cancel the 3's. It's largely due to the fact that that plus sign's in the way right there, creating a binomial, and we're not allowed to cancel. So that's our final answer. Okay, our third example, the only real curveball we've thrown at you is we've thrown a division sign here in the middle instead of a multiplication sign. The good news is that changes very little about what you're going to do. According to PEMDAS, you're still going to start with your parentheses. We're going to take care of what's inside of these parentheses. What do you think your common denominator should be? Hopefully you said r. I'm going to use a denominator of r for both of these. That means the second fraction does not change. It remains 6 over r. The first fraction, or the first term, used to be a 1. Now it's going to be r over r. If I combine those two, I'm going to get r plus 6 divided by r. Okay. Now let's see if we can clean up the second fraction. What do you think the common denominator should be? I'm going to use r again, meaning the second fraction does not change. Now here's the trick. The first term used to be an r, which was equivalent to r over 1. Now if I multiply the top and the bottom of that fraction by r, the numerator now turns into r squared. So make sure we've got r squared over r for that first term. If I combine those two terms, I will now have r squared minus 36 divided by r. Okay, now we hinted at the fact that we had a division sign in the middle. We said it's going to change something. What it's going to do is we have this goofy saying called keep, change, flip. Keep refers to the first fraction. We're going to keep it as is. Change refers to the operation. We're going to change from division into multiplication. And flip, of course, refers to that second fraction, which we're going to take his reciprocal and flip him over. Now I'm going to try to kill two birds with one stone. Keeping the first fraction here as is. Not only am I going to flip that second fraction, but I'm also going to factor the r squared minus 36 as I'm flipping it. Okay. If you want to break this into two steps, you can. But if you feel comfortable doing it all in one move, that's great too. We're looking for things that we could simplify or cancel out. We could say the quantity r plus 6 cancels the quantity r plus 6, and of course the r cancels the r. Now, when you cancel those r's, really what's happening is we're saying r divided by r is equivalent to a 1. I think that 1's extremely important in this situation because we're going to write our final answer as 1 over the quantity r minus 6. If we just wrote r minus 6 rather than 1 over r minus 6, our answer would be completely off track and we wouldn't receive the credit we would hope for. So there's example number 3. Let's hunker down and go get one more. Our last example looks even more frightening just because the first quantity we have here is a trinomial, but that doesn't change how we're going to approach this problem. PEMDAS says we're going to try to simplify everything in this set of parentheses first. What do you think your common denominator should be? Well, right now your denominators are a 1, and an x. When I consider those three denominators, I'm going to say x should be my common denominator, which means that third term does not change. I'm going to multiply the first term by x over x, thus giving me x squared in the numerator. I'm going to multiply the second one by x over x as well, thus giving me 7x in the numerator. If I clean those three terms up, I'm going to say x squared minus 7x plus 10, all divided by x. Then we can come on over here, and common denominator will be an x. So that stays 5. If I multiply this term by x over x, I will get x over x. Combining those two terms, I could say x minus 5 all over x. Okay, here's a case. Again, we've got the division just like we had in the last problem. I'm going to go ahead and use my keep, change, flip philosophy. While I'm keeping this one oriented the way it was previously, I am going to factor it. So I'm thinking x minus 5 times the quantity x minus 2. We're going to change our operation to multiplication, and we're going to flip this second fraction over. Okay, we see some good things happening. X minus 5 kills the x minus 5. The x kills the x. Those are both 1s once we cancel them, of course. Now, how are you going to express our final answer? Does it need to be 1 over x minus 2, similar to the last problem? In fact, it doesn't. The quantity x minus 2 is sitting in the numerator. If we multiply it by the other numerator of 1, we simply get x minus 2. If you wrote that on top of 1, that wouldn't be bad. It's just unnecessary, and we could say our final answer is just x minus 2. So today we saw a combination of adding and subtracting fractions as well as multiplying and dividing fractions. As long as you feel comfortable getting a common denominator, I think you're going to be extremely successful tomorrow. So good luck, and we'll see you tomorrow.